This model is 84% accurate, and that number is honest. Your curriculum has a lesson on ethics. Every intro AI course does, and every one of them teaches the same sentence. Models can be biased. Students learn the sentence. They can repeat it on a quiz. Almost none of them have watched it happen, and that's nobody's fault. You can't put it on a slide. You need a model that actually runs, real data with a real gap in it, and a control the student can grab and move. This is that. One link, no install, works on a school Chromebook. It's MIT licensed, so if you want it for lesson 11, it's yours. Here's the data. 1994 US Census, relabeled as a loan decision. No bank ever made these calls. The label is income over a cut-off, which isn't creditworthiness, and it isn't merit. It's a record of what the 1994 job market paid people. Wage gap and all. And I never gave the model anyone's sex. Watch it find the gap anyway. That trained in a fraction of a second, right here in the browser. No server, no API, nothing to log into. 3-to-1, men to women. It got there through marital status and occupation. Delete the sensitive column and the bias walks back in through the side door. 1 control, this line. Everyone to the right gets approved. Everyone to the left gets denied. Keep your eye on the accuracy. Two-tenths of a point, that's the whole change. Now look over here. The share of women who'd have paid the loan back and got turned down anyway went from about half to 7 in 10. It got worse for men too. It got worse for women faster. Nothing crashed, nothing turned red. The accuracy number never moved. That's the whole problem. Accuracy is the one thing we teach beginners to check, and it's exactly the number that holds perfectly still while this happens. There's no language model in here, and that's on purpose. An LLM would explain fairness to the student. I want the student producing the evidence. Being told something and catching it yourself don't land the same way. And the whole point is the second one. Second dataset. This one's synthetic, built for teaching, based on a real study from 2019. A hospital risk algorithm was flagging black patients far less than white patients who were just as sick. Nobody gave it race, they gave it cost. So in here, the label is what patients spent, and spending tells you who got care, not who was sick. The label is already wrong before the model ever sees it. All right, let me fix it. I get a separate threshold for each group. Every fairness metric on this page is now under 5%, every single one. By every definition on this screen, I fixed it. Now look at what it cost. I got there by approving almost nobody. In either group, I didn't make it fair, I stopped helping anyone, and the app says so out loud. That's the reason this exists. You can satisfy a metric completely and abandon the thing it was meant to protect by accident, meaning well, with a dashboard telling you good job the whole way down. On how it's built, the model is a logistic regression I wrote by hand, 60 lines, no ML library. A script in the repo runs scikit-learn on the same split and checks mine against it, and they agree to 7 decimal places. Another one tests every claim these dataset cards make against the generator and fails if they disagree. A third walks every threshold pair and proves there's no setting that closes all the gaps. 3 commands. You can run all of them yourself. 6 fairness definitions on screen at once. Confidence intervals on every gap. 3 datasets with 3 different broken labels. And a worksheet with an answer key, so a teacher can run this tomorrow. I'll be honest about the size of it. No student has used this yet. It won't make a single deployed system fairer. What it might do is change what one person notices. Somebody who's watched an accuracy number sit perfectly still while a denial rate climbed is going to ask a second question every time they see one, for the rest of their career. You're not choosing whether to be unfair, you're choosing who absorbs it.